Our goal today is to look at section 3.5, which is on performing basic matrix operations. And that's what we're going to be doing. We're going to be using operations with matrices. A matrix is a rectangular arrangement of numbers in rows and columns. So when we talk about the dimensions of a matrix, it's a matrix with m rows and n columns are read as m by n. So it's an m by n matrix. So we're always going to go, how many rows does the matrix have? That's our first number. And then how many columns does the matrix have? That's our second number. So again, rows go across and columns go up and down vertically. And then the element is the number in a matrix. So there's a whole bunch of elements depending on what type of matrix it is. Equal matrices means their dimensions are the same and the elements in the corresponding positions then must be equal. So we're going to look at adding and subtracting matrices, and they're both going to be the same. So we're going to take a 2 by 2 matrix with A and B being row 1 and C and D being row 2. We're going to add it to the matrix EF and GH. So notice here, this is a 2 by 2 matrix added to a 2 by 2 matrix. So when we add these, it says to add or subtract two matrices, simply add or subtract the elements in the corresponding positions. You can add or subtract matrices only if they have the same dimensions. So they must be a 2 by 2 and a 2 by 2, or a 5 by 5 and a 5 by 5, or a 1 by 7 and a 1 by 7, as long as they have corresponding elements. So if we look at this, this is going to be A plus E. Then the second one, it's going to be B plus F, because those are the corresponding elements. Then the third one, we have C plus G, so that's going to be row 2, column 1. And then if we look at now row 2, column 2, that's what we would get for our matrices. We would just add those elements up. The same thing is true if we end up doing a subtraction problem. So we're going to have A, B, and C, D. And again, we'll subtract these same two matrices. And this time it'll be A minus E, and B minus F, and C minus G, and D minus H. And so that's what our matrix would be in that case. Now, it may make more sense if we just look at an example. And so we'll look at example A is an adding two matrices, and example B, we're going to be subtracting two matrices. So again, we're going to add the corresponding elements. So we have a 2 plus a negative 3, which is negative 1, 4 plus 2, which is going to be 6, 0 plus 4 is 4, and 1 plus 0 is 1. So our answer, when we add these two matrices together, is simply that. Row 1 is negative 1, 6, and row 2 is 4 and 1. So we're going to do the same thing with the subtraction. Now this is a 3 by 2 matrix, 3 rows, 2 columns. And the second one is a 3 rows and 2 columns. So we can do those. They have the same dimensions. So we're going to subtract them. We have 4 minus 2, which is 2. 6 minus 3, which is 3. Negative 2 minus negative 4, which is going to give us a 2. 2 minus 2, which is 0. 1 minus negative 3, which is 4. And 5 minus 1, which is 4. So again, then our answer will also be a 3 by 2 matrix. We're also going to talk about something called a scalar, and that's a real number by which you multiply a matrix. You can kind of think of it as like the distributive property. A scalar multiplication is a multiplication of each element of the matrix by a real number called a scalar. So when we look at example 2, we're going to take that 4 and multiply by every element in that problem. So it's really kind of like a distributive property. We're going to take it to all of those in here, multiply every one of those elements by the 4 to get our answer. And so this is going to be 12 and -8 and 0 and 12 and 4 and 24. And so here is our answer. And again, this one is also going to be a 3x2 matrix. Now the same thing is going to happen in B. We have a 2x2 matrix multiplied by a scalar, -3. And then the second one is also a 2x2 matrix. So we can add those together after we do the multiplication. But the first thing we need to do is the multiplication. So it's going to be 3, -15, -12, 0. And then I have my matrix. So now that I have two matrices, they're the same dimensions, I can add them up. So it's going to be 1, -14, -7, -3. And there is the answer that we get when we do that one. So the next thing that we're going to look at is some guided practice problems. And if you'd get your books open to page 188, there are 4 guided practice problems on there. So why don't you go ahead and get your books open and do those problems. Go ahead and pause the video, and then you can hit play when you're ready to move on. And here are the guided practice questions, the answers for those. Notice in number 1, it was just an addition of the 2x3 matrix and the 2x3 matrix. Number 2, we subtracted those 3x2 matrices. Number 3 was a multiplication of a scalar. And then number 4, we multiplied the 2x2 matrix by a scalar and then added those together. So the next thing we're going to talk about is the properties of matrix operations. So it says let A, B, and C be matrices with the same dimensions and let K be a scalar. The associative property of addition works for matrices. The commutative property of addition works for matrices. So does the distributive property of addition and the distributive property of subtraction. So the next thing we're going to look at is an example on page 189. And on page 189, it says that a company manufactures small and large steel DVD racks with wooden bases. Each size of racks is available in 3 types of wood: walnut, pine, and cherry. Sales of the racks for last month and this month are shown in the picture on page 189. We want to organize the data using 2 matrices, one for last month's sales and one for this month's sales. Then write and interpret the matrix giving the average monthly sales for the 2-month period. So we're going to set up a matrix for last month and for this month. All right, and last month they sold 2 different types, small racks and large racks, and they had walnut, pine, and cherry. So when we set these up, we're going to go walnut, pine, and cherry. I'm going to have small and large. So now we just have to put our numbers in. Well, how many walnuts did we sell that were small? And that's 125. How many were large? And that's 100. And in the pine, we had 278 small and 251 large and 225 small cherry and 270 large cherry. And we're going to do the same thing. So here's our matrix. Oh. I need to include that. Just our numbers. So there's our matrix. So we're going to fill those numbers in the same on this one. All right, so here's last month's matrix, and here's this month's matrix. Well, the question now asks us to make, it says, write and interpret a matrix giving the average monthly sales of the 2-month period. Well, average means we're going to add them up and divide by 2, which is the same as taking 1/2, and we'll call them A and B. So we'll call this first one A and the second one B. So we're going to take 1/2 and then add them up. And again, we can do this however we would like. So I'm going to add them up first, and then we're going to do the scalar multiplication after we've already added them up. That way we don't have to use the scalar on both of them, and we can just multiply our answers by 1/2 after we're done. So we're going to take and add these two together. So we're going to have 125 plus 95, and that gives us 220. And then 100 plus 114, which is 214. And then we have the 278 and 316. So that gives us our 594. And then we're going to get 466, 430, and 570. So if we take and do the multiplication now, we're going to get 110, 107, 297, 233, 215, and 285. All right, so this is our result matrix. Well, what we want to do is be able to interpret this. Well, so let's say we take this element right here. What does that really mean? Well, that really means, if we look at this element, that is pine, and it's a large. So it's a large pine rack, and that's how many we averaged in the 2-month period. So 233 was the average amount of large pine racks that we would sell. If we would look at this one, well, that's going to represent the cherry small racks that we sold as an average over that 2-month period. So there's a way to use matrices with our averages. Example 4 is going to be to solve a matrix. We're going to solve the matrix equation for x and y. So we'll write a matrix up here. All right, so let's say we're going to take 2 times the matrix, and we'll go 2x and a minus 3 and a 5 and a minus y plus, and then this 2 by 2 matrix would be negative 1, 4 in row 1 and 3, 5 in row 2. So we want to solve for x and y. We want to find out what those values are. And so it's going to equal the matrix 10 to 16, 14. So what we're going to do is we're going to simplify everything on the left side. So we're going to get 2 times And that's going to be 2x minus 1 plus 1. We're going to get 8. And we're going to get 5 minus y. And that equals, again, 10, 2, 16, 14. Oop. Okay. Now we have to do the matrix multiplication of the scalars. So I'm going to keep going over here on the right. So that's going to be 4x minus 4. 2, 16, and 10 minus 2y. And again, it equals 10, 2, 16, 14. Now, since we have one matrix equals to another matrix, they should be the same. Notice here, 2 equals 2. Those are corresponding elements. 16 equals 16. Those are corresponding elements. So we know that they have to be equal to each other. So we're going to take this row 1, column 1 element, 4x minus 4, has to equal 10. So if we do that, we're going to get 14 fourths, which means 7 halves. Oh, found a mistake. We have to go back and fix this. This should be a 4x minus 2, not a 4x minus 4. So up here, we should have a 4x. This should be a minus 2. Let's start this part again here. So this should be 4x minus 2 equals 10. So we're going to have 4x equals 12 and x equals 3. And then we have to do the same thing for y. We're going to take that. So we know that 10 minus 2y has to equal 14. So negative 2y equals 4. And y equals negative 2. So those are the solutions we get when we solve those. All right, so let's go to the guided practice questions, and those again are on page 190 this time. And I want you to do, just go ahead and do examples 5 and 6. You're going to use example 5 or example 3 to do question 5, and the number 6 is right in there. So go ahead and do those. You can pause the video and hit play when you're ready to move on. And here are the answers for those two guided practice questions. So section 3.5 was an introduction on using matrices. So when we looked at basic matrix operations, and those were adding two matrices, subtracting two matrices, and multiplying by a scalar. Now remember, the only time you can add two matrices together or subtract two matrices if they have the same dimensions. You cannot add two matrices that do not have the same dimensions or subtract them. And then the last thing we looked at is how to solve for a variable in a matrix. So we have to just simplify the matrix until we have one matrix equals to another, and then set the corresponding elements equal to each other so we can solve those. So here is your homework assignment for section 3.5. It's on page 190. I would highly recommend doing the quiz, section 3.3 and 3.5. That'll help you with your quiz that you're going to take, and that's on page 193, numbers 1 through 14. And then if you also look at page 194, there is a graphing calculator activity. They give you the directions on how to plug these things into your graphing calculators. And we're going to be using our graphing calculators later quite a bit to do matrix operations. So